Okay, so before we get started with Ixl level J K.5, it's probably a good idea to stop for a minute and talk a little bit about percentages. We've basically got two situations as we work in percentages with numbers and consumer math. We've got situations in which something is being increased. In this case, this could be that a tax is added, or a tip, or some kind of a surcharge or fee, shipping and handling, processing fee, those kinds of things. And then we also have situations in which the amount of money we're going to spend will decrease, and that could be as a result of a discount or something, a percentage off sale, or that by spending a certain amount you automatically are given a certain percentage refund as a rebate, which is basically the same thing as decreasing your total cost. So in general, what we're going to be doing when we work with percentages is going to be pretty straightforward. This is an approach that I've used with students for a long time, and it just seems to work pretty well. When I'm going to talk about increasing the cost of an item through a percentage, I'm basically going to take the cost of the item, which is 100% of itself, whatever the cost is. If I think about what's 100% of that cost, well, that's just that number. And then I'm going to add on top of it whatever the percentage amount of the tax or tip or surcharge is. So if it's a 20% tip, I'm going to take 100% of the number and add to it 20% of the number. And the reason I like to do it that way is it's actually pretty easy to realize that this means that the item's going to cost 120% of what it was originally, which means all I have to do is take the amount of the purchase. If I want to find 120% of a number, you've probably known for many years now that of in this context really means I'm going to multiply. So I'll take the amount and I'm just going to multiply by the decimal version of 120. Well, 120% is really 1.2 because the decimal, in order to make it a percent, the decimal was shifted 2 times to the right. So to make it back into a regular decimal number, I just put it back where it started, and all I have to do is multiply by 1.2, or 1.20, although that extra zero is really not needed. Similarly, if I look over here and I want to deal with a discount or a decrease or a sale, I take the 100% that I started with, and I simply subtract the amount of the discount or the sale or the refund. So let's say it's a 15% off sale. I want to take 100%, and I'm going to take away 15%. In this case, rather than adding, we're subtracting, and 100 minus 15 is 85. So if I want to find the new price after the discount or refund or sale, all I do is I'll take 85% of whatever the original cost was. And so similarly to what we did with the increase, I'm going to take the amount of the price of the item and multiply by the decimal version of 85%. Remember, 85% got to be that number by taking 0.85 and moving the decimal 2 times to the right. So we're just going to move it back to the left, and I'll multiply whatever the amount of the price is by 0.85. And thereby I will have taken away that 15% discount. So it's pretty easy. We're just basically going to add to or subtract from 100 and then do a little multiplication. Let's take a look at our first problem. Lisa bought a model railroad set online. The cost is $90.72 plus 25%. That's one of those fees there, shipping and handling. So what was the total cost? Well, remember, we want to take the cost as it was, 100%, and we're going to add 25%. And so that means we're going to have whatever that cost was, 125% of that cost. So the cost of the item was $90.72, and all I have to do here is multiply, definitely going to use a calculator here, multiply by 1.25. So $90.72 times 1.25 means the total cost with the shipping and handling is $113.40. Done. Okay, similar situation, a little easier now. We're going to just leave a 20% tip. And so just like we saw in the last problem, I've got the 100% cost of the restaurant bill, which is $17.15, and I'm going to add 20%, which means the total cost is going to be 120% of the bill. And so that means I'm going to take $17.15 and find 120% of that by remembering that 120% is really the same as the decimal 1.2. Remember, percentages are just another way to describe a decimal, and 100 times bigger, basically. That's what the percent per 100 means. It's been increased by 100 times. So to get it back to where it started as its real version of itself as a number, we move the decimal to the left, 1.2. So here's my calculator, 17.15 times 1.2. Before I hit enter, why don't we see if we can estimate? What do you think a good estimate among the choices there in Edpuzzle? What's the best estimate for the total cost here? And it turns out the actual amount, not an estimate, is $20.58 when I perform this calculation right here. Okay, now we're talking about adding a sales tax, but it's only 10%. So I've got the cost of the handbag plus an additional 10%. So hopefully by now you're starting to see this is actually a pretty simple process, really. As long as you remember how to turn a percentage back into a decimal before you multiply, we're going to take the $63 cost and multiply not by 110, but by 1.10. And I'm going to pause here. Go ahead and take a guess. What's a good estimate for the total cost here with tax? Turns out the total cost is $69.30. Okay, last one. This is a pretty simple case. In this case, they don't tell us in the wording of the problem what the situation is, but they give us the sign here, and we can tell from the sign that it's 50% off. This is the first one we've had where it's actually a decrease. So this time, instead of adding on top of 100%, we're going to take 50% away. Well, that's not too hard. 100% take away 50% means that the total cost is only going to be 50%. 100 minus 50 is 50. So the cost of the hat, $766, times the new cost will be 50% of the old cost, which means I multiply by the decimal version of 50%, which is just times 0.5. And when I do that, I'm going to, again, pause for an estimate. Go ahead and take a guess. What's a good guess for 50% of 766? And it's 383. I got to tell you, 766 was already a pretty good price for a cowboy hat. This is an even better price. I'm sure Dr. McGriff paid a whole lot more than that for the hat that he wore around this year. Hope these work for you. If you get stuck, don't be shy. Ask for help.